Hi everyone, in this video, I'm going to show you how to find the GCF of two numbers. So what is the GCF, or the greatest common factor? It's the highest number that divides exactly into two or more numbers. Now before I show you how to find the GCF, I want to review a few math terms that I'm going to use throughout this video. And in this video, I will demonstrate three methods to show you how to find the GCF of two numbers. The first term of this lesson is factor. A factor is a number that is multiplied by another number. Let me show you an example. So let's say we have the number 8. And we know that 8 can be divided by 1 to get 8. Or it can be divided by 2 to get 4. And if we write them as multiplication, we know that 1 times 8 equals 8, or 2 times 4 equals 8. So in this case, the factors of 8 are 1, 2, 4, and 8. So basically, if you see multiplication, such as 2 times 4 equals 8, you know that 2 and 4 are factors, and the number 8 is called the product. The second term that you need to understand for this lesson is prime number. A prime number is a positive integer that has exactly two positive divisors. One of its factors is 1. So what is an integer? An integer is number such as 1, 2, 3, 4, 5, like the counting numbers you learned before. And then you can also turn them into negative. So it would be like -1, -2, -3, -4, -5, and -6. And you also want to include 0 as the integer. So it would be great if you can memorize the first 8 prime numbers because they will be very useful when you have to find the GCF of two numbers. Let's take the number 5 as example. We know that 5 only has two factors, which is 1 and 5. And that makes it a prime number because it has exactly two positive divisors. And one of the factor is 1. Now, let me show you a non-example. Let's say we have the number 9. 9 can be written as 1 times 9. It can also be written as 3 times 3. And in this case, we know that 9 has the factors 1, 3, and 9. It has 3 factors. So it doesn't follow the definition of prime number, and that's why it's not a prime number. So the first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Now for the simpler examples, we probably will need the first 4 or 5 prime numbers. And in the second half of the video, I will show you a harder example, and you might need to use the following few prime numbers. And some people may ask, how come 1 is not a prime number even though it has a factor of 1? So we know that 1 can be written as 1 times 1 in multiplication. And we know that 1 only has one factor, which is 1. But in the definition, it says a prime number has two divisors, or two factors. And that's why 1 is not a prime number. The last term I'm going to go over is multiple. A multiple is the product of a number and any integers. So in this lesson, we are only going to deal with positive numbers or positive integers. So in this case, I'm only going to explain positive multiples. So let's list the first few positive multiples of 2. The way to get multiples is you want to multiply the numbers by 1, by 2, by 3, by 4. So the first few multiples of 2's are 2, 4, 6, 8, 10. And to get 2, you want to multiply 2 by 1. To get 4, you multiply 2 by 2. To get 6, you multiply 2 by 3. To get 8, you multiply 2 by 4. And to get 10, you multiply 2 by 5. Now you get the pattern. So we are going to do the same thing for multiples of 7. You can always show the work first if you can't write them down right away. So I'm going to write 1 times 7, 2 times 7, 3 times 7, 4 times 7, 5 times 7. So the first 5 multiples of 7 are 7, 14, 21, 28, and 35. So now that we went over the math terms needed for this lesson, I'm going to introduce the 3 methods of finding the greatest common factor of 2 numbers. The first method is to list all factors of each number. So for example, if we want to find the GCF of 8 and 12, we can list the factors of 8 and the factors of 12 until we find the GCF of both numbers. So for 8, I know that I can multiply 1 by 8 to get 8. Then I look at 2 and see if I can multiply any number to get to 8, and I know that 2 times 4 equals 8. And if you think about 3, I can't multiply 3 with any number to get 8. And it looks like we have to stop here. So the factors of 8 are 1, 2, 4, and 8. Now for 12, I also want to start with 1 first, and I know 1 times 12 equals 12. Then I go to 2, and I see that 2 times 6 equals 12. And we also have 3 times 4 equals 12, and looks like that's it. So the factors of 12 are 1, 2, 3, 4, 6, and 12. The second method is the ladder method, or we call it upside down cake method because it looks like a cake that's put upside down. So in this problem, we want to find the GCF of 30 and 36. Knowing the prime numbers will be very useful for this method. So to get started, you want to first write the 2 numbers in the first row. And then you want to find a prime number that is the common divisor of these 2 numbers. So it looks like we can pick 2 or 3. I'm going to start with the smallest prime number 2. 30 divided by 2 is 15, so I write 15 in the second row. 36 divided by 2 is 18. Now we're left with 15 and 18. We will look at the list of prime numbers again. And it looks like this time we have to pick 3 because 2 doesn't work. So 15 divided by 3 is 5. 18 divided by 3 is 6. Now the greatest common factor of 5 and 6 is 1, so it looks like we can stop here. To get the GCF with the ladder method, basically you want to multiply the 2 numbers on the left side. So the GCF of this problem is 2 times 3, which is 6. And some students might ask, can I divide these 2 numbers by 3 if I already know that these 2 numbers are the multiples of 3? Absolutely. You can basically find a common factor of these 2 numbers until you cannot divide anymore. So let's say we want to pick 3 first. 30 divided by 3 is 10. 36 divided by 3 is 12. And then we can continue and we see that 10 and 12 has a common prime factor, which is 2. 10 divided by 2 is 5, 12 divided by 2 is 6. And it looks like we will have the same number. 3 times 2 also gives you 6. The third method is to use factor tree. So a factor tree allows you to write a number in prime factorization. After you write the factor tree of each number, you want to find the product of the common prime factors of both numbers. So let's start with 12 first. First, you want to write down 12 on top, and then you want to write down the branches. You can pick a prime number, for example, the lowest one, 2. And you know that 2 times 6 equals 12, so you write 6 on the other side. Now we know 6 is not a prime number, so we're going to continue to write it as a product of a prime number and another number. So for 6, we also know that we can start with 2 first, and 2 times 3 equals 6. So it looks like for 12, the prime factorization is 2 times 2 times 3. Now let's start with 8. So since 8 is an even number, we can also write it as 2 times another number. And we know the other factor would be 9, because 2 times 9 is 18. And then for 9, it's not a prime number, so we continue. It looks like we cannot pick 2, so we're going to pick 3. And 9 equals 3 times 3. And we're going to bring down the 2 here. So the prime factorization of 18 is 2 times 3 times 3. Now that we finished the factor tree of each number, we want to find the product of the common prime factors. So let's circle the common prime factors. The first common prime factor I see is 2, so I'm going to circle it. And it looks like there's not another 2 in 18, so I move on to 3. And I can circle another 3 in 18 as well. So the GCF of 12 and 18 would be the product of 2 and 3, which is 6. So which method do you like? If you think this video is helpful, feel free to comment below or give this video a thumbs up. If you're interested in learning harder examples, please continue to watch this video. I'm going to show you another example with the 3 methods you just learned. So the problem is to find the GCF of 330 and 495. These two are big numbers. If you pick the first method, that is to list the factors of each number, it may take you a while. That's why I'm going to skip method 1 for now and go ahead to use method 2. So the first step is to write down the 2 numbers on the first row. And since I can tell right away these 2 numbers are multiples of 5, I'm going to pick 5. 330 divided by 5 is 66. 495 divided by 5 is 99. Now if we look at these 2 numbers, you see the 1's digit and the 10's digit have the same number. That means these 2 numbers are multiples of 11. So I'm going to go ahead and divide both numbers by 11. 66 divided by 11 is 6. 99 divided by 11 is 9. For 6 and 9, we can still divide these 2 numbers by another prime number, which is 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. And it looks like we have to stop here because we got 2 and 3, and the greatest common factor of 2 and 3 is just 1. So now I'm going to go ahead and multiply the numbers on the left side. So the GCF of this problem would be 5 times 11 times 3, which is 165. Now I'm going to continue to use the third method, the factor tree, to solve the same problem, so we can compare and see if there's any difference or similarities. So first, we want to find the factor tree of 330. And if you look at the prime numbers on the right side, it looks like we can either pick 2 or 3, and it looks like it's easier if we start with 3. So I'm going to write 330 as the product of 3 and 110. Next, we want to write 110 as the product of a prime number and another number. And I look at the list on the right side, I want to pick 5 because it's easier to write the product of 2 numbers. So 110 divided by 5. 2 5s goes into 10. And then I bring down a 10, and then I have 2 5s goes into 10 again. So it would be 5 times 22. And since 22 is not a prime number, I'm going to continue. I want to pick 2 this time because 22 can be written as the product of 2 and 11. And these 2 are prime numbers. So now I'm going to go ahead and bring down the other numbers I didn't bring down. It will be 3 times, 5 times, 2 times 11, and that's the prime factorization of 330. The next prime factorization tree we need to write is for the number 495. So again, I know that 495 is a multiple of 5, so I'm going to write it as the product of 5 and 99. And then we also know that 99 can be written as the product of 11 and 9, which we actually did in the ladder method before. So lastly, we just need to write 9 as the product of 3 and 3. And I'm going to go ahead and bring down the other prime numbers, 5 and 11. So the prime factorization of 495 is 5 times 11 times 3 times 3. Now that we finished writing the factor trees of both numbers, we want to circle the common prime factors and find the product of those common prime factors. So the first common prime factor they have would be 3, and the second common prime factor is 5. Only 330 have 2, so I don't need to circle anything. And it looks like we can still circle 11 for both numbers. So the GCF of these two numbers is the product of 3 and 5 and 11, and again that would be 165. Since I introduced method 1 listing all factors, I still want to show you what it looks like for these two numbers. As you can see, each number has a long list of factors. It would probably take you a while to list all of them, and that's why when you're finding GCF of great numbers, you don't want to use method 1.